Now, I'm not going to do it straight away, so don't get excited. I'll tell you when I'm going to do it. So, this was first done, as far as I'm aware, by a very famous scientist called Feynman, who's one of my heroes, actually. And it's to demonstrate the idea of conservation of energy. Now, somebody in last lesson talked about conservation of energy. Can you remember who it was? Somebody gave it as an answer to one of the to Dr. Willie Stutz's question. Can you tell me what conservation of energy is? This is the experiment. I'm going to illustrate it, hopefully, without taking my teeth out. So what I'm going to do is hold this here. I'm going to let go. The question is, am I safe? Am I? Why? George? Well, let's see what happens. I know it's are we ready?
Don't get chest.
Well,
yeah.
Let's leave all that.
That's it.
Sure?
Yeah.
Okay. Shall I do it again? Emily, did you capture that?
Yeah,
is that good?
Yeah,
I'll do another one just in case. You ready? Okay. So I'm not moving. Now, the point is you start off with one sort of energy, here, which I lifted up, and of course this goes back to what we've just been talking about. Because what I'm doing here is what? Have we got a tape measure? Just somebody tell you I need a tape measure?
Yeah,
I'll give you 1 second, 2 seconds. Okay, so we're going to do a calculation of this. How is this gaining energy? Think about what we've just been doing, right? Right, it's gaining gravitational energy, isn't it? Because it's off the floor here, so it's got some gravitational energy, but I'm lifting it up higher up, aren't I? In fact, I'm doing this. That's what I'm doing. That's the equivalent thing I've just done is that. But of course, a bit like the slope, I'm lifting it up like this. But the height I've moved it is exactly the same. So what I need to know, it's so close. You need to measure what height it is off the ground.
It is 150 centimetres.
And then you need to measure it here.
Uh, 46 centimetres.
And you were doing it to the centre of gravity, weren't you?
I was doing it to the bottom of the edge of the ball.
Non-physicist.
Okay, we'll call that 53 centimetres.
I used to work with friends.
And 157.
Okay? So what I've just determined is how high I've just lifted it, and therefore how much work I've done. Now in this case, that work is ending up as gravitational potential energy, because when I let it go, what's happening to that gravitational potential energy? What's happening to it? Yeah? It's being turned into kinetic energy. When's it going to be travelling its fastest? When's it going to be travelling its fastest? No? It's going to be slow then. It's at 0 here, isn't it? Absolutely 0 here. When's it going to be going its fastest? Yeah? When it's closest to the floor, here. Because at that point, all of the potential energy, or most of it, has transferred into kinetic energy. And I use the word transfer, I don't use the word use. And I'll explain why in a moment. It then goes up here, slowing down all the time until it gets up to about the same point it was before. It's got no kinetic energy again, because momentarily it's stationary. It's got maximum potential energy, and then the thing reverses back up to here. Why am I confident it's not going to hit my chin? Right.
Because some of the energy is already been transferred into kinetic energy, lost somehow.
No. Because that kinetic energy goes potential energy into kinetic energy, back into potential energy. That's the transfer. What are we not taking into account? Where are we? Go on. Yeah, there's a bit of air resistance, so the air particles are being warmed up, so I'm losing a little tiny bit of energy there. Anywhere else? Gravity's not going to take any energy out. Where else are you going to be losing energy? Yeah, the friction of the knot up here. You might even be losing a bit, if this isn't perfectly tense, by the stretching motion of this. You might lose a bit there, generate a bit of heat. Well, one thing is for sure, one thing is absolutely for sure, even if this was perfect and no energy was lost, and very little in reality is, I'm still safe. Why? Why am I still safe? Sorry? Yeah, so why am I safe? Why can't it come back and swing me and hit me on the chin and head?
Because it's made up into gravitational potential.
Yeah, what's the most gravitational potential energy you could have? What you had at the beginning. And at the beginning, it just touched my chin. So worst case scenario, it just touches my chin again. Isn't it? That's worst case. It can't gain energy, that's the point. Where does it gain the energy from? It would need a motor up there in order for you to get it to hit my chin. Why was I then nervous then? If I'm so confident, I'm such a good physicist, I'm perfectly safe, why am I nervous? It could snap and come barreling into me. This is looking pretty sturdy rope. What else? Yeah, if I pushed it by accident, I didn't just let go, I could have given it a little bit more energy than it had. Bang, but I'm quite clever, so I wouldn't do that. Yeah? Yeah, if I don't stay perfectly still and I move my chin a little bit forward, I was being asked, not to put my chest down, because if you hit my chest on the way back up like that would be quite painful. The thing I was also worried about is Mr. MacDonald was winding me up because he was saying this rope could stretch, and if this did elongate, remember the strawberry laces? Gets a bit further, bang, might hurt, something really I want to keep. Yeah, I mean, but ultimately, as long as I did it properly, I'll do it once more, in case anybody wants to film it if they missed it. I'm on pretty safe ground, a couple of centimetres of safety. Anybody want to go? No, I'm not going to let you. Because if anything goes wrong, yeah. So what we've got there is this principle of conservation of energy. You cannot destroy energy, nor can you create it. All you can do is transfer it from being in one form to another. And what this experiment illustrates is all of that, because energy is being changed from being in potential energy to kinetic energy and potential energy back again. And it shows you the principle of conservation of energy because none of that energy was lost. Neither did it gain any energy. And as you've recognised, the only way it would gain energy is if I gave it a bit of a push, which if one of you were doing, I might be inclined to do. Okay, any questions about that? Okay, wonderful. Thank you very much.